A buffer is a solution that can resist changes to pH upon addition of acidic or basic solutions. Buffers can either be a weak acid and its conjugate base, or a weak base and its conjugate acid, that are in equilibrium with each other. Buffers work by neutralizing and reacted with any added bases or acids to maintain a constant pH. For example, in the weak acid reaction below, if you add hydroxide, the reaction would shift to the right to create more of the conjugate base. And if you add hydronium, the reaction would shift to the left to make more of the weak acid. This constant state of equilibrium is what allows the pH to stay in a constant range. Weak acids don't completely dissociate in solution, causing the solution to be in a state of equilibrium between the weak acid and its conjugate. This is why weak acids tend to be used as buffer solutions. On the other hand, strong acids completely dissociate in solution, so there is no state of equilibrium. For example, hydrochloric acid, which is known to be a strong acid, would completely dissociate into hydronium and chloride ions when mixed with water. Now it's time for the technique. First, you need to obtain your buffer solutions. In this lab, we are using buffer with a pH of 4 and a buffer with a pH of 7. Now, grab your meter and probe from your TA and begin setting it up, making sure to be gentle with the probe as it's easily breakable. Next, remove the probe from the storage solution. Instead of doing as shown, you should twist the top off away from the storage solution to avoid possibly damaging the probe. Make sure to rinse off the probe prior to calibrating. Gently shake off the excess water into the waste beaker. Submerge the probe into one of the buffer solutions and gently swirl. On the lab quest, you can now begin calibrating. If you don't have a stylus, you can use a mechanical pencil with the lead retracted. Once the voltage value has stopped changing, you can enter the pH value of the buffer solution. Rinse off the probe and gently shake off the excess again. Now, submerge the probe into the second buffer solution and gently swirl. Enter the second pH value, tap Keep, and then tap OK. Now check to see if the correct pH is displaying. Rinse off the probe and place it in distilled water for future use. Allowing the probe to sit out in the air could cause it to burn out. Now it's time to determine the unknown pH of a solution. First, remove the probe from the distilled water, rinse it off, and shake off the excess. Submerge it in the solution and gently swirl. Record the pH once it's stable in your notebook along with the other pH values you've collected. Your data table should look like this. Finally, it's time to clean up. Rinse off your probe one last time and shake dry. Gently put the probe back into the storage solution and turn off the lab quest. Grab your probe and meter and return it to the front of the lab. Now, clean all glassware and utensils used in the lab. And finally, properly store them in the correct spot.